Good afternoon, everyone. Today, I'd like to talk to you about a topic very near to my heart, Android library development. Developing libraries is actually like a bit underrated if you ask me, because fundamentally, it's Android libraries, it's SDKs that like prevent us from having to reinvent the wheel all over again. So they're like a big part of what drives innovation within the ecosystem. So I'm excited to be talking about that. I'm Jeroen Mols. I work for a company called Plaat, and we're basically the easiest way to link your bank account to an app, and that way we empower innovators to deliver them access to the financial system. We have quite a few open vacancies. I work remotely for Plaat, so also remote vacancies. Not really on mobile at the moment, but feel free to check us out on our careers page. So, what do you want to do today? First, let's make it clear what you actually want to build. Then we're going to build it. We're going to have a look at like transitive dependencies, whether or not you should modularize your SDK. And then finally, we're going to look at some more advanced issues about transitive dependencies. Spoiler, they're a bit of a pain. And then wrap things up with some tips and tools. Okay, so in this talk, I'm going to use the term Android library or SDK interchangeably, but to me at least, they basically mean the same thing. So, what do we want to build? So, usually nowadays you have apps, and those apps, they use libraries like Jetpack Compose, or maybe like third-party libraries like OKHTTP, and those libraries come from Maven. And what we want to accomplish is we want to build our own library, similar to like an Android X library. Yeah, apps are also modularized. So we want to build like a similar library to Android X, publish it to Maven, so that our customers can just add a one-liner to their app and integrate their SDK. So that's our goal. All right, let's do it. We're going to build our first library. Of course, we're going to use our tool of choice. Let's just create a new project and, oh wait, there is no template to create an Android library. And this is going to be a recurring theme today. Like the tools to build Android libraries, unfortunately, they're just not where they should be. So what we're going to do instead is we're going to create a new app. So let's do that first. So we create a new application. We choose one of the activity templates. And now we're going to add a library module to that application. So we create a new module, and look there. We have an Android library. This is already looking better. Fine, we accept this. This is how our project currently looks like. So we have an app module that consumes a library module. So let's look at the library module. You can see where the red ball is. So it has a library plugin. So com.android.library. And if we look at the build.create file of the app, we can see that the app implements the library. So this is also kind of like a convenient setup, because an Android library isn't runnable by itself. So you would need to integrate it in an app to run it anyway. So now we have like an all-in-one project that allows us to do like iterative development on the library. How do we run it? We're actually going to run our library by running the app. So it's either via this Gradle command or via the UI. And if we want to test your library, we're going to invoke these tasks on our library for unit tests or for Android tests. Now, if we want to ship our library, we're going to run the following command on our library, assemble release, which is going to yield us, if it proceeds, which is going to yield us an AAR file. And I'll explain a bit more about what an AAR file is, but it's some kind of like zip file with the following contents. So it has some code, some resources, and so on. So let's dive a bit deeper into what an AAR file is. So probably most of you are already familiar with like APK files. It's like an application we install on the Android phone. Like APK files, they contain compiled code, processed resources, an Android manifest. But they also contain all of the transitive dependencies you use are also compiled into the app. So if you use OKHTTP in the app, when you build the APK file, OKHTTP will actually be present in the binary. APKs can be run on an Android device, and they're signed. A jar file, which is a Java archive, So this is actually the other extreme. This can only contain code. It's also used in the Java world, but you can also use it on Android. You can even access like Android APIs with it. That's not an issue. But jar files, they are not executable as such, at least not on Android, and they are unsigned. Now, what we're missing here clearly in the jar files is we also want to like ship resources into our Android library. So that's why the Android team came up with the Android archive, which is the same as a jar file, but it can also contain processed resources and a manifest. But there's two things that I want to point out here and the difference between an APK and an AAR. So one, an AAR doesn't contain the compiled dependencies. So the transitive dependencies aren't contained in the AAR. And the second thing is AARs aren't signed. So we won't need a signing configuration to build a release variant of our library. And then when our library is done, we're actually gonna build it, which I demonstrated to you before how we do that. Then we need to like generate a PGP key, publish it to verify that we're the owner of the PGP key. We need to sign the build, upload it to Maven Central. It's, to be very blunt, a tedious process. It shouldn't be that hard, but it is. But there's great tutorials, for instance, by Martin on how to do that. So I'm not going to cover that in this talk. But again, like tooling for Android libraries is lacking. Like, I wish that I could just like log in with my Google Play account in Android Studio, and that there would just be like a Maven repository hosted by Google, and just a Gradle task where you can say, hey, publish this and it's done. But unfortunately, that's not the world we live in today. So, now that you've built a first library, let's talk about transitive dependencies. So, if our library grows a bit bigger, this is still the project we created before, but at some point we may also start to use like external dependencies, like OKHTTP, but probably most Android libraries will also include one of the Jetpack libraries. So, remember what I told you before, like now this is a customer integrating our library. So I've told you before in the AAR file, the transitive dependencies aren't included there. So if a customer now integrates our AAR file into their app, they would actually also manually have to add a dependency on OKHTTP. Yep. Or otherwise, stuff wouldn't compile. So that means, instead of having this one-liner that we wanted to have, our customers would need to add 2 lines. So the question is, how on earth can we make it that our customers only have to integrate a single line? We want to have them to integrate a single line, and then they would not just get our library, but they would also get OKHTTP through our library. So in this case, the customer app doesn't have a dependency on OKHTTP, but by adding a dependency on our library, they're getting the OKHTTP dependency transitively through our library. So that's a transitive dependency. How does that work? Well, that's through a POM file, which is another Maven artifact. It's an XML file in which you can specify a bunch of metadata about your library, like for instance the group ID, the artifact ID, but you could also specify a description, a link to your source code, license information. You can specify quite a few things there, but we can also specify our transitive dependencies there. So by adding a transitive dependency in here, and also uploading that to the Maven repository, this is like, these are all of the files uploaded to Maven Central by plot with the SDK that we publish. And you can see there's basically 2 files, the POM file and the AAR file at the top, and then a bunch of signatures. But if now our customers integrate this one-liner into their app, then Gradle is downloading 2 files, the AAR and the POM, and then it knows like, oh, I also need to add OKHTTP and the other dependencies, and that's how everything is like hooked up together. Note that like libraries like OKHTTP, they publish even more artifacts like a Java doc, a sources.jar, so there's more things you can publish to Maven. Now, a very important thing to note here is that in our project, where we had the app module consuming the library module, like notice how when we added the OKHTTP dependency to the library there, like everything just compiles, it magically works. But if we upload the AAR file to Maven and we make a mistake in the POM, then suddenly it doesn't work because we're missing a dependency. So the way source code is linked together within a project between modules is different than how it's linked together through Maven. So it's really, really important to always, before you release, to publish your artifact to Maven and then exactly test that artifact. So at Plaat we have 2 test apps. We have one app where we just like do local development, iterative development, where we consume, the app consumes the library as a submodule. And we have another test app where we actually consume it through Maven. We add a bunch of other things like common dependencies, and then we test things there before releasing. Modularization. So nowadays, quite a few apps are modularized. This is like a way it could be done. I have some blog posts and even a talk on this. But because modularization has quite a few benefits, which I'm not going to get into now, that makes us wonder, like, should we also modularize our SDK? So let's do exactly that. So we're going to add 2 more modules to our SDK, a database module and UI components module. The way we can do that is just add a new module in Android Studio, again an Android library. And then in our library build.gradle file, we are actually saying like, hey, this module depends on the database and UI components. So the resulting project we have is, we have 3 modules, 4 modules. We have the app module that integrates the library, and then library integrates database and UI components. We're going to add a bit of simple code in here just to link things together. So app initializes the library, calls library.initialize. The library initializes the database, database.initialize, and the database just prints out something. Okay, let's see whether that works or not. And you can already see it's not going to work. So if we now build our AAR file, and we do this, forget about this, it's just like a trick to directly consume the AAR file in a project. But if we directly include the AAR file in the app module, we build the binary, build will be fine, there will be nothing wrong, but you then install it on a phone, we run it, and suddenly we get this crash. And it says can't find the database class. So let's take the AAR file and actually see what's inside. And we see that the library class is inside, but the database isn't. And if you're then wondering like, hey, shouldn't like the Android Gradle plugin fix this for us? Yeah, I'm wondering the same thing, but there's actually an issue open for this already for 4 years. And unfortunately, it still hasn't been addressed. So, what does that leave us with? There's a few things we could do. The first thing we could do is, instead of like only publishing our library to Maven, we could also publish the other 2 submodules to Maven. So we also publish UI components and database, and we change the code into the build.gradle file of our library, and we say, instead of using like database as a submodule, directly consume it through Maven. Now, this will work, and it will work fine. Like the Android X libraries are like the living example of that. But there's other companies like Square who are doing this. But that's like a few challenges. So one, if you now want to make a change to a database, you would have to change some code in the database module, open a pull request, wait for it to be reviewed, then it needs to be built on the CI, published to Maven. Once it's published, you need to promote the build. Then here you can upload the build number, so the version number of the database, and only then you'll see your changes in the app, which you can already tell like it's not a great developer experience. So this is mostly only going to work like if you either have really great tooling to do this, or if the modules don't really change that frequently. And then another downside is, so if you look at database, like imagine if we publish database to Maven Central, it looks as if we've made like an additional library for customers to use, but it's not, right? This database is nowhere near the same as like what Room is, for instance, because Room is like a general purpose database that everybody could use for anything, whereas this database only works with our module. So it's kind of like we're shipping our project to the outside world, and that doesn't really make much sense. Okay, so is there another thing we could do? Yeah, we could make a fat AAR. So it's exactly the same as the previous AAR, only all of the code from the submodules will also be packaged in. It's actually fairly easy to do so. We apply a plugin, we change the implementation keywords to embed, and that's it. Now suddenly all of the submodules will be packaged in our AR file. Few downsides though. The first one is, the way this works is the plugin actually hooks into a specific task of the Android Gradle plugin. So if the Android Gradle team decides to change the name of a task, which they've done in the past, then this breaks. And if this breaks, the library author is quite amazing, he would update it in a week or two. So that's not really an issue, but still, it doesn't feel quite right. The other disadvantage, but that's a bit more advanced, depending on how you add transitive dependencies to your submodules, it could significantly increase the binary size of your AAR. So in order to combat that, you could work with compile-only dependencies, which is a bit more involved, but there's a way to get around that. Just know that if you use this, also have a look at your actual AAR size. It might be bigger than you expect it to be. And then the last solution is just do a single module SDK, and then these issues go away. There's actually also a second problem with modularization, and that is, let's look at the Kotlin keywords. So there's this great Kotlin keyword, internal, which allows you to expose the interface of a class to all of the other classes within the module, but nobody externally can access it, which is great, right? But we kind of wish we had the same thing, but then for a project. If our library wants to initialize a database, it needs to access the database.initialize method. And the only modifier we have to enable that now is the public modifier. But if we add a public modifier to our database, then not just our library can access it, but also the application can access it. So I kind of wish there was a project internal modifier so that all of the modules in your project could access it, but nobody outside, but that unfortunately doesn't exist. What can we do to reduce our public API surface? Because if we don't do anything, all of the public methods, so all of the methods used by modules from the submodules, they will all be exposed on our public API. The easiest thing we can do is we can just for instance, take the database as an example, we just move all of those classes to an internal package. This just is it's a hint to developers hey, this is internal, you should probably not be using this. But it doesn't prevent actual usage. This is, for instance, OKHTTP does it. OKHTTP has a OKHTTP.internal package. Another thing we could do is we can also say let's take all of those classes from those submodules and let's obfuscate them. Then other people could still use them, but then at least it's not apparent that they can use them, or it's very hard to be able to then actually call a useful method. Now this idea is actually pretty great, we also use it, but you shouldn't do it in this way. So here we've just run ProGuard over the API of our submodules. You shouldn't do it like this, because if two libraries do this, they're probably going to end up each with an a.a.a class, and within an APK file, each class can only be defined once, so this is going to cause conflicts. But there is a really cool ProGuard or R8 rule to do that, so you can actually say repackage classes, and then it's going to add a package name prefix to all of the classes and flatten them all into a single package. So this is how we currently expose the API or hide the API from our submodules. And then last but not least, you could also just do a single module SDK. So let's wrap things up. For modularization then, modularizing SDKs it doesn't have the same economics as modularizing an app. So I would say don't go through the effort, especially not for small or medium-sized SDKs, unless Android fixes this issue, obviously. So I would just say try to keep single module, use a package name instead, and once your library or your SDK evolves, maybe at some point you do want to spin off something that's more useful, for instance your internal UI library, which you then also reuse in your app or something, so then it might make sense. But when you do, make sure like to reduce the public interface and just know that like tooling isn't going to work in your favor. Okay, let's move into transitive dependency conflicts. This is going to get interesting. So we have our customer app, and they're integrating some library. Now they're adding our library to the mix, and like each of those libraries is using like a few transitive dependencies. There's actually two things that can go wrong here. The first thing is like those transitive dependency versions, they could conflict. So for instance, if like an app is using like our library and another library, and imagine that like another library is relying on OKHTTP v3 and we're relying on OKHTTP v4. Well, now in this case, because I told you like every class can only be defined once, so the build system will have to make a choice which version of OKHTTP to include. And that varies a bit per build system, but Gradle will pick the biggest one, or like the highest version number. So it's going to pick OKHTTP4 in this case, which is fine, right? Like OKHTTP is a really good library, they're backwards compatible, this shouldn't really cause issues. Except when it does. Because in OKHTTP 3.13, they dropped support for older Android versions, and their min SDK is SDK 21. So imagine that here. So imagine here that the customer app is targeting older Android devices. Suddenly they include our SDK. Gradle decides to serve them a newer version of OKHTTP, which doesn't support those old Android devices. The build will be just fine, but at the runtime, this is going to blow up on like old user phones. So it's tricky, right? So what can you do about this? So first, the customer can actually force a particular version of OKHTTP. I'll explain a bit more about that later. But we, in our library, we can also like loosen our version requirements. Like, do we really need the latest version of OKHTTP? Maybe we need to be a bit more lenient to avoid conflicts like this. And then, like, similar to modularization, we can also decide not to use a transitive dependency, because there can't be a problem if there isn't a dependency. So let's have a look at like forcing the dependency. So this is done by our customers in the customer app. They can actually say like, hey, I want to use your library, but not your OKHTTP version, so exclude that. Or they can do it at a project level, in their top level build.gradle file, and then you basically tell Gradle like, hey, anytime when you try to pick a version of OKHTTP, pick this one. So the great thing about this is like, this will always work. This will always work. We won't need to update our library. Our customer is in full control. They can always do this. The downside is our customers are forcing us. So they're suddenly forcing our library to work with an older version of OKHTTP, which could work, I guess, but at least like I didn't test for that, right? So like you never know like what mileage you're going to get. And then lastly, like, yeah, we're also putting the burden on our customers to fix that. I actually want to look at like, I want to make a small detour here and look at like a special case, because there could be cases where Gradle can't actually make a good decision. Like before with OKHTTP 3 and 4, like, okay, it was very like nuanced, it picked a newer version and an old Android support got dropped. But in this case, it's completely different, because in OKHTTP, the public API was different in v2 and v3. So they dropped a few methods, they dropped the getter and setters of all those methods. So if like, imagine if a project is using two libraries, they're both relying on a different version. Like, no matter what version Gradle picks, this will never, like it will compile, but it will never work, right? So the way OKHTTP handles this, and this is very interesting I find, is they change their package name. And because all of the v3 classes are in a different package, they can actually coexist within the same customer app. So like, imagine in that case, if it happens, it might be less efficient because you may end up with like duplicate resources, like duplicate thread pools and so on, but at least it will work. And they've done another clever trick, which is update their Maven coordinates. So also in the Maven coordinates, they've renamed it to OKHTTP v3. So now from Gradle's perspective, like this is a different artifact than the previous artifact. So Gradle will never automatically try to like upgrade that to the new version. So interesting tip if you ever have to handle breaking changes. All right, next problem, dependencies could be like downright incompatible. So let's look at this example. So this is actually something we've run into, like we use protobuf, and protobuf, there's multiple protobuf artifacts available, like protobuf-java, protobuf-java lite. Doesn't really matter like what they are, it's just the right one is optimized for like Android, it's smaller, but the left one is just for Java, but they're the same thing, they just contain slightly different classes. So imagine if both of these are included in the same app and you build it, you're going to get a build error because it's a duplicate class exception, because both artifacts define the same class. And then you may say like, yeah, but this is really an edge case. Well, we've had a customer that was using Firebase performance monitoring, a version of give or take like a year old. And they were using even another artifact of protobuf, which was 4 years old and unmaintained. And then suddenly that customer added our library, and they started to complain with us like, hey, the build doesn't work and it's because of Plaid, but yeah, there's nothing that we really could do in this case, right? We just happened to be like the last SDK added, and hence we came on the radar. All right, so what can you do about this? So again, the customer could do a similar trick where they force a particular dependency like before. We can actually remove a transitive dependency from a dependency of ours, which is pretty cool. I'm going to explain a bit more. Or we just stop relying on a dependency. So the way we ran into this is we were using a library called PBNK, which is great, by the way. It's like a Kotlin runtime for protobuf and a code generator. And they are actually a Kotlin multi-platform project. So they weren't specifically targeting Android, and hence they were using like the protobuf-java variant. Whereas on Android, you should ideally use protobuf-java lite. So what we wanted is, we wanted to use them without relying on that dependency. So in our pom.xml, we've actually changed the PBNK dependency and added an exclusion. So we told in our pom file, we want to use PBNK, but please exclude this from that. Which then yields, yeah, this is how you do it in Gradle, which then yields the following. So then our library was only using PBNK and not transitively serving yet another dependency, which is cool, right? Just make sure to also add the dependency that you do want to use back, because otherwise, like if a customer app only uses your library, it would be missing protobuf, so you have to explicitly add it yourself back. So what do I recommend with regards to transitive dependencies? Try to use as few of them as possible. Like there's a few issues that are just fundamentally very difficult to solve, and like the fewer dependencies you're gonna have, the fewer of those issues you're gonna have. And when you do use a transitive dependency, first make sure it doesn't have any known security vulnerabilities, and second, use a stable version. Imagine if we would start using like an alpha version of Android X. That could be fine for us, but if a customer then integrates our library, they're suddenly going to start using like an alpha version of Android X, which could be fine for them, or maybe not, I don't know, but it's not up to us to make the decision whether they should be using alpha libraries or not. So it's important to use stable versions. Don't use the latest version. We tend to use versions that are like half a year to a year old, because it also takes our customers a few months to actually adopt our SDK, so then we're like lagging like a year and a half behind, which reduces most conflicts. Sometimes we deviate from this. For instance, we added in, I think in April, pretty soon, like in April, the new activity result API got launched. So we immediately added support for that, which was pretty cool. But then we had to use like the latest version of Android X.fragment. And that's something we added to our release notes. Like, hey, look, we had to do this because of this reason, and then like our customers would be able to figure that out. All right. Should you run into like a transitive dependency problem, there's a really great Gradle command you can run, which is just a module and then dependencies. You can actually also add a filter like dash, I think it's dash dash configuration, and then you can just like filter for release runtime class path, and then you only get like a single configuration. And finally, like with regards to transitive dependencies, like it doesn't matter if you're doing the right thing or not. Like the last SDK that gets added to an app, from a customer point of view, it's like everything was working. We now add you, whether it's your fault or not, you're going to get the blame because you were just the last one added. All right, some tips and tools. First, library resources. So by default, all of your library resources, they're going to be public. So that means if a customer integrates your library, they use Android Studio Autocomplete, they will see all of your library resources. There's a way to hide those, which is by defining a public.xml in resources values. And you just need to define the resources that should be public in here. What we do is we just define like a single resource that's public, like a library name. And for the rest, like all of the rest is then becomes like private by default. Private meaning that Android Studio won't suggest you to add those, but there's nothing preventing our customers from actually like guessing what our resources are and then using them. Like you can't restrict resource usage. Another interesting thing is if we define a string like no network, for when there's no network, that's the message we show. Well, if our customer defines the same string, no network, they're actually going to override our version. And it's even worse than that, because if there's another library that is also defining the same string, and both of them get merged in, then the first library that's defined in your Gradle dependencies, that's the one that's going to win and override the value. So in order to like prevent that, because resources don't have namespaces, you can add like a prefix to all of your resources to make them look unique. And then like the chances of like the overriding happening is way smaller. Unfortunately, there isn't any tooling to help you with this. So this is a manual process. You need to like manually name all of them. There's a configuration in your build.gradle file where you can say like, hey, this is the resource prefix I want to have. But this just gives Android Studio a hint of like, yeah, if a resource doesn't have this prefix, I'm going to show a warning, but that's it. So it doesn't enforce this. It only works in Android Studio. So yeah, that's it about resource name. Let's now talk about source and binary compatibility. So that was getting interesting. So imagine if a customer is using the first version of our library, and we release a new version, library v2, which has like a slightly different API. So in v1, we have an API just initialized, which doesn't take any parameters. In v2, we actually add a new parameter. If our customers now bump the version in the build.gradle file, their build is actually going to fail, because we added a parameter to our public API, and they are not implementing that yet, so then they basically get like a compile error. So this update wasn't source compatible. A way to solve that is to provide a default value for the parameter. If they then bump their version, everything is good and everything will compile. Okay, so this update is source compatible, but this is also binary compatible. If we look at the bytecode of our first library, it defines this method, which is initialized without parameters. If we now look at the bytecode of the second method, which has the initialize with the default parameter, it has an initialize method which takes the Boolean parameter, and it has like a method generated by the Kotlin compiler, which looks different from the parameterless initialize method. So it doesn't actually have the no parameter initialize method. Even though they were source compatible, their bytecode looks different. And then you may say like, yeah, but this isn't really a problem for our customers, right? Well, the case is rather advanced, but it could happen. So imagine if a customer app is using the v2 of our library, and there's some other library that is using v1 of our library. If we set this up in Gradle, Gradle needs to pick what version of our library are they going to use. So they're going to force the highest version. But the other library was already compiled because the an AAR contains compiled code, so it won't be recompiled. It's going to expect the method without a parameter, which isn't going to be there, which compiles just fine, no problem with the horizon, until you actually run this code on a device, and then it will crash at runtime. So with this topic, which is super interesting, there's 2 great blog posts, one by Martin again, and one by Jake Wharton, which dive way deeper in binary and source compatibility, also in some unique challenges with Kotlin. I highly recommend that if you're interested in this. But a simple tip I can give you now is there is actually a plugin provided by the Kotlin team. And that plugin, you can just apply it, you can set up some configuration, and if you then run the task API dump, it's going to take a snapshot of your public API. And if you then run the task API check, it's going to check all of the changes that are currently in your code base against that snapshot. So this is a way to make sure that that you're maintaining source and binary compatibility. Then next tip is we should minimize your API surface. Already covered that. These are some of the advantages you have then. A way to do that is you can configure the Kotlin compiler by adding this to the Android block compiler options. We run it in explicit API mode. And if you add this, then the Kotlin compiler will actually throw errors once you're not explicitly defining the visibility of a method. So here, by default, everything in Kotlin is public, which is unfortunate, it is. But we might miss this, so now here we need to define that it's public to satisfy the compiler. Then if you want to develop experimental APIs, it's a quick tip. So you can actually define your own annotation, like experimental my library API. So this is if you want to add a new API to your library, but you're not ready to fully commit to it yet. You can create your own annotation, slap the @requires opt-in on top of it, then annotate the new API in your library with that annotation, and if now somebody wants to use it, they will have to explicitly opt in before they can use it, which is a neat mechanism to let an API incubate. There's actually 2 experimental APIs, one provided by Kotlin, one provided by Android X. The difference is the first one, the Kotlin one, it's validated by the Kotlin compiler, so only works for Kotlin code. The second one is validated by lint, so it works in both Java and Kotlin code. 2 more quick tips and then I'm done. So for deprecation, if you need to deprecate an API, there's 2 cool things you can do. You can provide a replace with. This allows IntelliJ to do a quick fix, so now they can just do Alt-Enter, and all of the instances of initialize will be replaced with initialize with the default value. Or you can also say I'm going to deprecate this method, hide it, but still keep it to maintain binary compatibility. So if we would have done this in the previous case where we added a method to a public API, this method would still be there in bytecode, so this change would still be binary compatible. And then lastly, you can actually ship a ProGuard configuration directly in your SDK. You just figure out what should the configuration be that our customers need to add. You put them in the consumer rules file, and then they get packaged into your AAR file automatically. So let's wrap things up. So libraries are super important because they're one of the key things that drive the innovation in our ecosystem. Tools are lacking, unfortunately. Try to minimize your API surface. Limit modularization. The economics, unfortunately, aren't there. And reduce your transitive dependencies as much as you can. These are some, if you want to read more about this, I actually write a blog. I have quite a few posts on modularization and also library development, so feel free to check that out. The image credits, quite a few other links to amazing blog posts that if you want to learn more about these things. And that's it. Thanks all for coming.